Yeah, so in the continuation to that, without electricity, women and girls have to spend hours fetching water. Clinics cannot store vaccines, we discussed before. Many school children cannot do homework at night, and people cannot run competitive businesses. Slow progress towards clean cooking solutions, affecting both human health and environment. And if we don't meet our goal by 2030, nearly a third of the world's population, mostly women and children, will continue to be exposed to harmful household air pollution. This is also one of the most little known or discussed topics about IAQs, indoor air qualities, right? So various regions, if you see, like as like a simple as like women has to run long distances to fetch water. School children, they cannot do homework at night time. Businesses cannot run, industries cannot run, right? Slow progress towards a cleaner solutions for the everyday cooking, the kitchen cooking, right, and other things. And then lastly it mentions about indoor air pollution. So that indoor air pollution, if you see, if somebody is running using firewood for kitchen things, okay, of course there will be fumes of different types, right, which are going to get accumulated in their hut, okay, in a small house. Okay, there may be a little opening or almost no opening, or maybe only an entrance or something, like depending upon that space. Okay, a highly concentrated amount of those emissions, those gases are going to get expose them the householders for an extended period of hours, and over a long period of time, that's going to cause health issues to them, right? So those, like even in the urban scenarios, when there is no ventilation from outside, if doors and windows, everything is closed, right? So that poses a very difficult situation, like there is no fresh air change, right? And as long as there is no fresh air change, the inhabitants are exposed to their own exhaust of this COU, which is CO2, which is coming out of our nostrils, right? So and an extended exposure to that CO and CO2, right, it's going to cause several short term as well as long term issues from a health perspective, right? So again, energy and you see health, how it is connected, directly connected. Well, what are the consequences to the lack of access to energy? Lack of access to energy may hamper efforts to contain COVID-19 across many parts of the world. Energy services are key to preventing diseases and fighting pandemics, from powering healthcare facilities and supplying clean water for essential hygiene to enable communications and IT services that connect people while maintaining social distancing. Well, what can be done to fix these? Countries can accelerate the transition to an affordable, reliable and sustainable energy system. Transition. Okay. So moving from a conventional this firewood based solutions to the more a cleaner a format of energy systems towards that side, by investing in renewable energy resources, prioritizing energy efficient practices and adopting clean energy technologies and infrastructure. Businesses can maintain and protect ecosystems and commit to sourcing 100% of operational electricity needs from renewable resources. Employers can reduce internal demand for transport by prioritizing telecommunication and incentivize less energy intensive modes such as train travel over auto and air travel. Investors can invest more in sustainable energy services, bringing new technologies to the market quickly from a diverse supplier base. You can save electricity by plugging appliances into a power strip and turning them off completely when not in use. So this is also most simple solution at everyone's end that we can save energy, including your computer also, because in the sleep mode also they keep on consuming some power. You can also do the same while utilizing your own a physical abilities. You can walk for short distances instead of taking a vehicle, right, or maybe take public transport instead of using personal vehicles, okay, to reduce overall carbon emissions. For more details, please see this website. Yeah, Some facts and figures. So before pandemic, efforts need scaling up on sustainable energy. 789 million people lack electricity as per 2018, and after COVID-19 implications, if you see, affordable and reliable energy is critical for health facilities. Of course, very critical. Otherwise, a lot of things cannot be done. Like like oxygen supply, storage of vaccines, storage of several other types of like a perishable like a medicines and like a vaccines and like injections and stuff. Plus like a operation theater like activities cannot be actually undertaken without electricity, like and several such like scanning and all of those things, like a medical tests and pathological tests and things, and they cannot be conducted without electricity, right? So healthcare facilities are so much dependent on like healthcare, and the facts suggest that 1 in 4 like a such like healthcare facilities are not electrified in some developing countries as of 2018. So 25%, 1/4, Speed of efforts in renewable energy are needed. 17% share of renewables in total energy consumption as per 2017. So only 17%. This must go higher. Energy efficiency improvement rate falls short of 3% needed. So 1.7%. Energy efficiency improvement rate. So that has also fallen short, as expected. Financial flows to developing countries for renewable energy are increasing. 21.4 billion US dollars as per 2017, were like a given for like these purposes, goes to LDCs, low developing countries, but only 12% goes to the LDCs, okay, remaining at other places, okay. So that is also a difference, out of this like a big budget, 21.4 US billion dollars, like only 12%, almost 1/8, little less than 1/8 goes to the low development countries. Some more latest data for primary indicators of global progress towards SDG 7 targets: 840 million people without electricity access, 3 billion people without clean cooking, 3 billion out of 8 billion, 17.5% total final energy consumption for renewables. Okay, this must go up. 5.1 megajoules per US dollar primary energy intensity. Okay. 2020 data on primary indicators of global progress towards SDG 7 targets. So as per 2010 and the latest year 2020. Okay, so in a span of 10 years, let's see, 1.2 billion people without access to electricity, and here this has reduced to 789 million people without access to electricity. Okay, so in a span of 20 years, there is a significant improvement, but still a huge figure, 700 like 89 million. 3 billion people without access to clean cooking in 2010, and 2020 this has reduced slightly to 2.8, so 0.2 billion like a people have been provided with the clean cooking solutions, so that's encouraging. 16.3% share of total final energy consumption for from renewables, that has increased to 17.3. So at least 1% increase in 10 years. 5.9 megajoules per US dollars to 5 megajoules per US dollar. Okay, so this is the primary energy intensity. There is also like this figure, and then we have lastly 10.1 US dollars, 10.1 billion US dollars international financing flows to developing countries in support to clean energy, and that has increased to 21.4 to developing countries in support of clean energy, and the previous slide suggested 21.4 billion. Out of this, only 12% goes to the LDCs. Okay, so in this one, well, it says flows to developing countries, but the previous slide suggests only 20% of this figure reaches to LDCs. Yeah, some targets under goal 7: universal access to affordable, reliable and modern energy services. Sustainability: substantially increase the share of renewable energy in the energy mix. So conventional energy mix and renewable energy mix. So in that one, considerable share should increase from this sector, renewable energy sector. Double the global rate of improvement in energy efficiency, 2x rate of improvement, twice. Enhance international cooperation to facilitate access to clean energy research and technology. Yeah, so this is also an essential factor. For example, like a lot of these technologies are patented, and yeah, their intellectual rights and commercial rights are reserved, and yeah, so that also poses some form of a difficulty and a higher a pricing for this to reach to the LDCs, right? So there should be some mechanism to escape or maneuver around that and make this technology, clean energy technology, available to LDCs. Expand infrastructure and upgrade technology for supplying modern and sustainable energy services for all in developing countries. So you can see in this slide, the share of population with access to electricity in 2018 is given. So here with this dark, this burnt sienna, we have 10 to 50%, up to, and here 50% to 99.9% population with access to electricity, and then light yellow is the 100% one, right? So light yellows, I think this North America, then in Southern America we have Brazil and Chile, etc. Then this northern, I think most of the countries in the northern hemisphere, okay, except here Mongolia, okay, and North Korea. North Korea, it seems, is in the lesser half one, okay, and this Mongolia is in the central one, 50 to 99%. India also falls under the same category, 50 to 99%, and most of these African nations, if you see, including Madagascar, they are under 10 to 50% range, okay. And yeah, South Asian countries, mostly Southeast Asian countries, ASEAN, this is all under a middle range. Yeah, and some from Latin. So this is this distribution. So we know where to intervene majorly, into which regions. The 20 countries with the largest excess deficit, 2010 to 18. So in this one we'll see here we have excess rate in percentage, percentage of the total population as per 2018, and on this side we have annualized average change 2010 to 18 percentage point, up to 8, okay, this is here. So this is the world average at 0.8, right, percentage points, and this is world average here at 90%, for excess rate. And in this one, if we see countries India, it is here in this range, Bangladesh, Pakistan, then Myanmar, Sudan, Nigeria, Angola, and then these blue ones, these lower middle income countries are depicted in green, and low income countries are in blue. So if you see, their distribution is towards a lower side, so these are in the range of from almost 10 to 50, 55, and lower middle income countries, it begins close to 40, it goes up to 100%, right? And on this side also, this distribution is largely from a 0 to mostly 4. Typically, if I take this, Kenya is here close to 7 on this side. So this shows a largest excess deficit. Yeah, so I would recommend for you to watch this video. You can see the link in the description. You can watch it. Yeah, this picture I found in one of the UN's documents, and you see the expression on the grand lady over here. She's so amused and pleased. Well, the incident is like that. For the first time in her life, she has received like this electricity connection, and this bulb has actually like a glow, is glowing in her like a household for the first time in her life. Okay, so you can see like that glow coming on her face also, how pleased and how happy she is. Okay, so definitely we would like to see many more such faces, and I hope very soon this target we are able to achieve. Okay, so coming down again, change in share of renewable energy in total final energy consumption between 2010 and 2017. So it is depicted over here. Gray is like no data available, very few countries. Top 20 countries are depicted by like this marker. You can see that blue marker. I think here India is also them. North American, Brazil, and many in Europe, and China, Russia, Japan, and one here. So this light green talks about decrease in renewable energy share. This dark green talks about increase in renewable energy share. So if you see, India has fallen into the decrease in renewable energy share category as per like this report. Okay, this is from 2017. Maybe you can visit like this link, this website, and check for the like a latest data in the recent years, because 2017 is still like 5-6 years like before. So I'm sure there may have been like some improvement. Okay, and yeah, increase like North Americans, and here European mostly, China, and yeah, this side Australia. Percentage of population with access to electricity. So if you see status in 2000, like year 2000, this was at 78% with access to electricity, right? Progress between 2000 to 2010, and this has reached to 83%. Next it reached to 90%. By 2030 it is projected that 93% of like a population will have electricity connection access, and remaining 100%, let's see by when it happens. But definitely I think it is on the fast like a progress. I think if it reaches here by end of 2030, I'm sure that will be a very good like achievement in terms of progressing, because like if you see this number of households which are short of like a such like a facilities is running in millions, right? So it's a huge task, and where all of that fund and resources are going to come to facilitate that is a big like a challenge. Okay, so you should refer like World Bank's and IEA website for latest like a data. Yeah, another like a picture, if you see annual increase in access to electricity rate in excess deficit countries 2010 to 18 percentage points wise. Okay, so annual excess growth rate falling, that is in pink. So very few countries, right? And then we have annual excess growth rate between 0 to 2 percentage points. This burns sienna, mostly African countries, Pakistan, and Indonesia also. Annual excess growth rate above 2 percentage points is the yellow one, including India, and achieved universal access between 2010 to 2018. If you see, is the success story. So many from this South America, Mexico, few in Africa, only few, I think 3 I see here, and then China and few more like Iran, and I see Vietnam here. Yeah, they have achieved. Okay, so how to measure this thing? Like there may be a question like how do you measure, how much of electrification has been done, and this in detail and with the accuracy. Well, a technology has come to the like rescue of like such kind of situations, to figure out quite reliable like a data to validate this, because all of these projections and things will go haywire if the data is inaccurate, right? So a validated data, a proven like a data set is also essential to carry out like credible like efforts like at the targeted locations. So if you see this like slide, it suggests about how do they like measure it. Okay, so this picture, if you see, this is from Eritrea, around Asmara is that like a place. It's a night light areas around Asmara, right? So well, there are a lot of like satellites hovering in the like space right above our heads, like a few hundred kilometers above like the Earth's surface, right? And they do like this job of using like a remote sensing and all, okay, of like a collecting, gathering like a data from like such remote places, because practically it is very difficult or next to impossible to access like a such like a difficult terrains for like a accurate like a data, right? So yeah, so this is where a technology has come to the rescue. I'll just read. Satellite images captured at night are proving to be a promising source of data for measuring access to electricity. The images show the emission of light around the globe, providing a record dating back to 1992 between the DMSP OLS and VIRS platforms. Non-human sources of light, such as lunar reflections and fires, can be removed, producing satellite data with compelling images of urbanization, access to electricity. Analysis of satellite imaging can reduce the lag in tracking the progress of electrification, particularly in fragile and conflict-affected countries where household surveys and sensors have conducted infrequently and irregularly, leaving substantial data gaps. To create the image in figure B1.1, like this one, a year's worth of nighttime light imagery, if you see, is processed to create a single indicator of the likelihood of electrification, shown by the shaded green squares. You see them, these shaded green squares, with a resolution of around 500 meters. The images are further filtered to find points significantly brighter than their surrounding, producing regions of excess black outlines. By overlaying this and population data, red pixels, it is possible to create disaggregated estimates of excess. It is also possible to go further, using additional data to quantify not only excess but also the percentage of connections within each area. Satellite imagery can therefore complement the end user data available from household surveys such as the multi-tier framework. The approach has several limitations, however, as coarse resolution and large regional differences which must be overcome through further research. Granularity is limited by the amount of light that can be picked up from space. Industrial complexes and street lights are bright, whereas satellite sensors may not be able to pick up light emitted from houses or offices. Off-grid sources may be particularly hard to capture because of dimmer light. Okay, you can refer like this source for more details. So this is how actually like such like a datas are gathered, collated, and then presented for like a policy decisions or action plans. Top 20 countries with the largest share of solar lighting systems below tier 1 2018. So if you see this country, Vanuatu, okay, this is almost 100% dependent on like a solar power. Okay, share of population connected to off-grid solar light supply, almost 100%. Okay, it's a small like island nation where because of its geographic like a challenge and limitation, there are limitations in terms of like energy generation plants also, like what they can establish, right? So this is the one of the most feasible and yeah, practical solution in that country. That's why this has the like a tremendously high ranking compared to the next, like a second one in this, like a range, tier 1. Second comes Kenya, Fiji, Mauritius, Rwanda, Samoa, Uganda, Senegal, Papua New Guinea, Benin, Jordan, Somalia, Burkina Faso, Malawi, India, Zimbabwe, Ethiopia, Sierra Leone, Tanzania, Mali. So India also, if you see, is here. This is close to around 7%. So the share of population using solar lies less than 11 watts, like a capacity, that range. Targets and indicators for SDG 7. So let's see what are the targets. By 2030, ensure universal access to affordable, reliable and modern energy services. By 2030, increase substantially the share of renewable energy in the global energy mix. By 2030, double the global rate of improvement in energy efficiency. By 2030, enhance international cooperation to facilitate access to clean energy research and technology, including renewable energy, energy efficiency and advanced and cleaner fossil fuel technology, and promote investment in energy infrastructure and clean energy technology. Yeah, indicators. Yeah, direct relation. If you see from renewable energy, like this SDG, right? So it is directly connected to several, like economic growth, upliftment, like poverty, hunger, overall climate change, and water related things, water and sanitation. Okay, so direct connection. Here in the slide you can see some interactions between sub indicators, within on the left side, and between, right, protected SDGs, trends until 2030. So well, 17 are listed on this side, and you can see trade-offs indicated in red color, so ranging between -1 to -0.6. non-classifieds, so -0.6 to +0.6, this range, and then synergies 0.6 to 1 is represented by green, right? So in this one you can see over here interactions between sub indicators within left and between right, projected SDG trend until 2030. The color bar represents the share of trade-offs, orange, synergies green, and non-classifieds yellow, observed within a goal. The grey bar depicts insufficient data for the analysis. The number in boxes represent the number of data pairs used for each analysis, and yeah, this is sourced from UN. You can see the numbers. Yeah, again mapping, if you see, compared to other, like SDGs, so you can see direct influences, no poverty, decent work, economic growth, industry, innovation, infrastructure, sustainable cities and communities, climate change, life on land, partnerships for the goals. And then from there it is connected to like many others also, like hunger, it's connected here. This one is connected to no poverty and again zero hunger and good health. Well, this one, industry innovation, will help responsible consumption, fighting climate change and partnerships. In sustainable cities, it's about partnerships and good health. Then climate change overall, it's about health, water, life below water, life on land and everything. Okay, so this is how it is, touching the other SDGs. With this, we have come to the end slide where we'll be seeing UN environments, like a shortlisting of some challenges and solutions. So let's see the first one. 1 in 5 people still lack access to modern electricity, and 3 billion people rely on wood, charcoal or animal waste for cooking and eating. Okay, previously we saw, which have I think a lot of difficulties for the householders, for the people, even like kids, they cannot study in night easily. If there is no electricity, they cannot actually store their food stuff, there won't be any refrigeration facility, right, and so on. In health we saw like a safety of vaccines and medicines, other stuff. Okay, what can be done? Ensure everyone gets access to clean, affordable, reliable, modern energy. So this mechanism actually should be distributed, should be actually connected to the last person. Then only we can say yes, the target is achieved. Secondly, every year indoor air pollution kills 4.3 million people, most of them women and children. 4.3 million people, 43 lakh people. Invest in renewable energy and disseminate its uses so that everybody gets to know what it is. Energy provided by fossil fuels is the main contributor of climate change, representing 60% of all greenhouse gases. Fossil fuels, hydrocarbons, the direct culprit, the major culprit. Well, what to do? Put in place energy saving policies and slowly and gradually get rid of hydrocarbons, right? So I think now we have understood under like this SDG, like affordable and clean energy, how it is important to go for it. It connects like all of us, every like a member, every section of the society. Hence it is very relevant. So with this we have come to the end of this lecture. Thank you all for joining. See you in the next one.